Yeah, start. So as I said, title is local empowerment using energy, and I'm mechanical engineering professor, so it's more like a mechanical way, right? So we apply relative technologies, so, electronics and very simple coding, etc. So you wanna, move next page, please. Right, so the title is Service Research and Learning. So usually in university, professors or student can be the participant on research. Right, we develop something new, investigate, experiment, and analysis. Those main research work in university. Of course, because it's university education institute, we teach and learn. Right? And the service. Service is something to public or society or community. So usually those research education service is separate. It's not linked together, but somehow I see those is combined if you have a certain approach. So I'm going to share that work. So if you are in the university, maybe you can try and maybe you agree with me later. Okay, next page, please. Yeah, the terminology, appropriate technology, it can be in other wording like technology for life or something. It's a little the fashion, like this wording. Some or university country they don't use this wording appropriate technology because it seems it's a little low tech. It's not advanced. So the wording is from a book called "Small is Beautiful." This is written by Ernst Schumacher. Dr. Ernst Schumacher is a German origin and the the professor in the United Kingdom. Then he made this intermediate technology in his book. So later on, people change intermediate technology to appropriate technology. So these typical examples are shown in the bottom. So in the middle, the light straw is a temporary filter. So several dollars of cost. If you buy it, then you can drink water, right? Any kind of water, then that can protect your diarrhea for 6 months, right? So the bacteria and or other debris will be filtered. 99.9% will be filtered. So left side, I'm drinking the pond of water in my school, Seoul National University. Okay? So that's good, appropriate technology product. One drawback is it's not forever. After 6 months, you need to buy again, or you need to give them for free. The right side is Q drum. That's the tire loop water carrying device. You put the water, and instead of carrying by jar or container, the little kids can roll the tire if the ground is flat because it's shape is cylindrical and the tire. It's easy to carry water, right? But again, the drawback is the cost. That drum is about $50, and without donation, they don't have money to buy those. So anyway, so that those kind of simple technology we call appropriate technology, and in this talk we to improve these appropriate technology devices using some ICT. Yeah. Next page, please. So I have a class. This is called different name, the design for manufacturing, that's official title, but this is project-based class, and we apply the appropriate technology concept to the device. So one of them is this rehabilitation device for helping the people having difficulty to walk. And the right side is a cooler of the worker in the shipbuilding company. So very simple idea. Student developed a project with the student, and then they apply to real field sometime. Next page, please. This is example in Tanzania. So the students are sitting with me down in there, and you see the outside of the door there is a trampoline. There's a rubber sheet, and then a spring in there, so this student can jump around. And in Tanzania, it's the kind of middle school with 700 or 800 students. You never see this kind of toy. So if I make a kind of volunteer, then several hundred people just lined up, and then they play whole day, right? And if you see the cable or pipe tubing from the trampoline toy to the inside of this room, there is a little the regulating container. This is a power generator. Power means this air. So if you go to dentist, the way of working drills to machine out your teeth is usually this compressed air. So to compress the air, you need electricity. But in this village, and most of village, like in the sense of 80-90% of local village in Tanzania or other countries like Ethiopia or Nepal, the chance of having electricity is less than 20%. So most of the cases, you cannot find available electricity. Without electricity, you cannot have a dentist service. So this idea of appropriate technology, we kind of accumulate the energy by the kids, the activity. Right? It's just a fun activity, and we can compress air. Then we can run the dental drill. So dentist is helping the local maid to having this kind of tested. Okay, that's this one of the examples. So in school, you can, that's okay. You can make this new device and then test in developing countries. Okay, next page, please. Right, then this activity, the first time started in 14 years ago. It's 2010, in it's kind of a student club in my department, mechanical engineering, that time mechanical and aerospace engineering. So every Wednesday lunchtime, we had a service meeting. So we pray God and read Bible, and students give in turn give a sermon or sharing the or her life. And then suddenly we decide to go to Nepal to do some engineering activity. And before that, we had a Nepali student in my laboratory. It's in the right side of the picture. His name is Binayak Pandari. He's now in Australia. And he asked me to do some volunteer service in very mountainous area of the Nepal. So, yeah, suddenly we teamed up, then prepared what to do. Okay, next page. Next page. For this project, we named the Solar Project, and then the team's name is Solar Volunteers. So that is from our Christian Fellow of Department. So again, this renewable energy, wind, solar, and micro hydro is our goal, and then we try to implement the grid system, local power system, and the village. So using solar panels, battery, and LED was introduced in 2011. So we tried to use those technologies and then move to Nepal. Next, please. Yeah, so Korea is like -7 degrees now, right? And Malaysia is much warmer. Nepal is in between China and India, so that's uh, it's like a mild, but in Himalaya it's much colder, even colder than Korea, -40, right? Very cold areas. So next page. The environment give some limitation, but first time we had to go to very small village called the Lama Hotel. So that takes about 1 day by car and change the car, and another day, full day walk. So going there takes 2 days. I think that's a relatively short time in Nepal for us. Very difficult. Next. So like this, the problem, we just entered the first village. So the next day we need to walk. But the villager said, because of a landslide, the one of American citizen got killed, right, by rocks and then this, right. So we need to suddenly change the route. So the route is very narrow and it goes up more than 1,000 meters up and down. So 88 hours we walk in the rain and with leeches and some animals. So it was very challenging. Okay, next page. So we worked very hard, but we put this in the Seoul National University SNU Mission Impossible. You know the movie Mission Impossible by Tom Cruise is very challenging, and then this was challenging for us too because we have only 1 week of a schedule. Right? So 7 days we visit the village. So as I said, going there takes 2 days, and coming back takes 2 days. So we have about 2 days of working, right? Full 2 days of working, and then a little extra time. So the village we never been, and we planned well, but the construction of this very simple metal frame was very difficult because the frame didn't come on time. So first day, we did wiring. Okay? So this wiring of 8 village houses, it's like 100 meter or I think maximum like 200 meter apart village, 8 houses of a hotel, very small hotel for tourists. And this one day is gone for the wiring, and the second day still frame didn't come. So the left side is 3 p.m. of the second day. So in the mountain, the sun sets early, so we have about 6 hours, maybe, or even 4 hours of the work. If you cannot complete, then the system failed, so mission is not accomplished. But suddenly, this frame came, and then we worked very more serious way, right? So at 3 p.m., I thought, yeah, this project is failed, but successfully in this right side, the bottom picture, 8 p.m. We are wiring the last connection. So all the batteries arrived, and then the connection is made, and then please go to next page. Yeah, so the second day night, you see the LED light on the kitchen of this village. So this is a hotel. Probably you don't see this kind of hotel in city areas, but yeah, no electricity, so fire, wood is a fuel, and this hotel worker do for us. Yeah, this is a map. This is Google Earth. So I make the next plan in 2012 and 13. So this is the area of 4 square kilometer. So you see the Mount Everest back there. So this is southern part of Nepal. Altitude is not that high. It's about 1500. So this is kind of a area we cover, and the village people is about 1,200 people, and area is very large. This is like 4 square kilometer, and we didn't have money. Right, this is volunteer work. We applied to Korean government for this funding, and we got some funding. It's for 2-year funding. Like 200,000 US dollar, or at that rate, that time, 250,000 US dollar. Then we want to construct the solar, wind, and hydro for 1,200 people. Okay, next page. And this is the initial picture, of the second year. Okay, so the local villagers are standing with the missionary, Korean missionary. Can you tell the Korean missionary here? Probably you cannot, because he looks exactly same as Nepali. He lived there more than like 12, 13 years already. So he looked very local people, and in the middle with the flower necklace and then cap, right, hat. He is the missionary John in Nepal. So he communicated with local people, and my student Binayak Bandari, who initiated this project, they work very hard and persuade the local people, because this requires 3 months of the construction without paying any money. Yeah. So just imagine, go to the village and tell them we'll construct electric circuits and the power plant and lighting. So your village will be changed, but you need to pay your role of the labor. So it was very challenging, but it turned out the villagers agreed. And then construction started. Next page. And we go to the village. Sometimes we do this kind of medical camp. It's very remote people, village, so people cannot have medical services, and we just invited this Nepali dentist and the Nepali doctors, 4 of them, and we pay them, and they check these local people in having medical camp. So about like 800 people came for 2 days. Next, please. Right, so this is the scene, right? Scene of the village, and this we had 3 eventually, but there's no good road to carry the devices, so everything we need to get it from local. Okay. Next page. So small hydro plant requires the head. Head means like a difference from the water tank to a turbine. So this turbine, we designed, Vinayak Bandari studied this, turbine shape from the book, and then make the computer-aided design shape, and then make it by the casting. So this is about 30 centimeter diameter turbine, and 100 meter of altitude change is easily available in the park. So little pipe in the middle picture, that's about 30 centimeter diameter pipe, and then that's connected from the top of the mountain to the power plant area. Okay. Water with this energy, right? The additional energy, and then going down, and then it turns the turbine, and turbine is connected to the generator. Okay. Next page. So the left side is the amount of water from the local fall. So very little water, but that water amount is enough. Right? So that means in any Nepal village, you can make this kind of plant. And in the middle, up there is the water tank reservoir. So that much of a water tank is enough, but construction is needed. And another main labor from local village is down there. So we need about 170 pole of electric connection. Local people go to the jungle, and then they cut out 170 of the very strong pole, and then that was done. And the video right now is showing the small 3 kilowatt of wind power plant. So standing the plant is very challenging because there is no this motorized or powered devices. So everything should be local labors and human labors. Yeah, that's one of our issue we need to consider. And down there is the construction of power plant building. So that is stones from the local area. So just imagine, building the stone base and then house. It takes 300 people for 3 months. Okay. So finally, the power plant is constructed. So the penstock pipe is all connected, and then electricity is carried to the village with higher voltage, 11 kilovolt, and then used by local people, 220 volt. Left side is showing the turbine and power generated from the water. So that's a 20 kilowatt of solar plant, we call friendship plant, is constructed, and after construction found that this example is first in the world because in this altitude 1,500 or 2,000 meter height, and the 3 hybrid system. So that is solar, small hydro, and this wind, and actually people using it until today. So that is research. It can be research. We started with volunteer service, but because it's the first time in the world, then it can be research if you have enough time to publish paper. So Vinayak Bandari got his PhD with this result. Okay. Next page. Yeah, so this is the map. Actually, this is a map before we go, without going there. Right? So Vinayak Bandari and I sit together in my office. Then we just draw the red electricity connecting planning. So 2 villages, left side the Korkok village and right side the Tingam village. So two different tribes, and they don't actually or see each other. Right? One Tingan is mountain top, is valleys. But with this electric system, they work together for the construction and then share the power nicely. Okay. Next page. Then before COVID, we started about the vaccine carrying ideas. So vaccine is very important for the health for any people. So without electricity, you cannot store vaccine in local areas. So the vaccine should come from the big city, and vaccination campaign is help the local people temporarily in irregular basis. So we try to make a little container. It's powered by motorcycle generator. Electricity is used, and it then have a GPS sense the transmitter. So with this motorcycle powered vaccine cooler, we can track the vaccine's location and condition. What is the temperature? Because vaccine should be kept in the temperature between 2 to 8 degrees. Most vaccine, COVID vaccine, you have a minus 50-degree vaccine. So we tried this. That's another way of using electricity for local people. Next page, please. Then we moved to Tanzania. So we constructed like 4 or 5 power plant in Nepal every year. Then 2017 to today, our base in Tanzania. Tanzania is even lower. I think this equator on the equator, so zero, right? Is the kind of warmest or hottest region. Let's move on. Next page. We built a center called Innovative Technology and Energy Center. It's funded by National Research Foundation of Korea for 4 years. So left side of this region, the region is Arusha. Arusha is a city as well as a region. Left side is Kilimanjaro, famous safari, region, and then right side of Arusha is the mountain Kilimanjaro, and this very popular area. And we tried to build a solar power plant there, and then using solar power for lighting, and then lighting in-house and water pumping and other extra work for the packaging or other needed for the local people. Yeah, so the maps, Serengeti left side, Kilimanjaro right side, we built 4, now is 5th power plant is in the local area. Right? So we put different name like Hope, Life, Friendship, and Karama. So those are our solar power plant because it's in equator. And then water is not enough. Right? So we cannot construct a small hydro, but solar is the only solution here. Okay. So this is the first solar plant in Karama. So 10 kilowatts, and the issue was the management. So management means the collecting the repair or maintenance fee from the local people. So we made a committee. So they themselves collect the fees for the electricity consumption, and they need to accumulate the money for the future repair or maintenance because this is electric system, and then by thunder or lightning it can be broken, or by local water, humidity, rain, wind, it can be damaged. So that's necessary, but the people unfortunately didn't agree to collect the money at the beginning. So they verbally agreed, but after 1, 2, 3 months later, I heard that people didn't pay. So we decided to change the system. That's prepayment system. So in order to make a prepayment system, you need to have a little computer, right, for each house. So without any electricity, without any internet communication, then making the electrical and the communication system in very inexpensive way, that's appropriate technology. So we decide to use Arduino. Arduino is like $10 microcomputer, and with the LoRa communication, LoRa is a 433 megahertz protocol of communication. So the controller we call smart meter is developed, and then like the graph, we could see the consumption of each house. Then they need to pay money. Then credit is charged to the power meter. Then once you use up, then power credit zero, then electricity is disconnected. So that's kind of a technical enforcement of the managing the payment. Yeah, so the left side is another village and the power meter, smart meter, and right side is virtually in the powerhouse. There's a solar power plant. Inside there is one laptop computer. Laptop computer collect all the data and it can share the status of the power consumption of each house. That can be monitored, and then again, this kind of local, very small village, entire system constructed and communication is constructed. So one of a student, Chinese student in my lab, he got a PhD from this research. Next page. And during COVID, we tried to make the mask, right? Mask was not available in local area. So with the clothing companies material, the electric powered sewing machine and local people made this for themselves. Yeah, this is for the water well. So with this solar plant backside, that's not for giving the electricity of local houses. This is for pumping. So with very little battery, during only the daytime, the water pumping of underground water. So the water is scarce, and these guys with me, they are digging the ground for the pipe. So the pump is right next to the solar plant, and then we want to send the water to 1 kilometer away to the village areas. Next, please. So this is the one of the water tank in the village. We have 2 tanks pumping the water and stored in its tank, and then people have water. Okay. Yeah, next. So the motorcycle guy, he is neighbor village people. So they put this water into the container and then carry to their house. Each house is, and the right side is tap water from the well. Next page. Yeah, so that's what I'm saying. If you have energy, right? So like 5-10 kilowatts of the energy, you can pump the underground water, and then without the area of the water, you can access the water source. Energy gives water. And this is another program we are running in the same area. This is with Hanyang University and Seoul National University together, Russia Technical College and E3 Empower. So this is education. So education is very important in many, or actually countries. But yeah, next page. We cannot go there and teach. So we go there sometime, but most of the time by online, like this conference, right? So we post these big screens, and then the local people, Dr. Herb Ree, he is the local director. He and his wife, Jiyoung Lee, and Jiyoung Lee is the director of E3 Empower. They stay there full time. And we send a video, and we sometimes go there in person and teach. Okay, next page. So this is mechanical engineering course. They don't have a bachelor's degree program, so we are developing. And this year, December, we'll have a first batch graduation ceremony in Arusha, Tanzania. So it's like 30 people at bachelor's of mechanical engineering. So this mechanical engineering experiment with the CNC milling, drilling, material testing, and computer coding is in one of our programs. So this is mechanical testing, right? Then material testing machine is shown, and then 3D printed white part that is designed, and then 3-point beam test, and they predict a failure load and failure location, and actually 3D printed part having different from this regular polymer material. So they experience this kind of manufacturing and then design. Okay. And next project we are doing is electric mobility. As many countries, probably Malaysia too, right? In Southeast Asia, I see a lot of motorbike used. And then nowadays, electric motorbike available, but in Tanzania, it's not there. So we make this hub motor. So the back wheel is the motor and then controller. So the frame is old motorbike. Students are good at welding, so we teach them to make this electric motorbike in the local university. Next, please. So this is a rural area, and the electric motorbike designed and manufactured by ours going to the solar power plant. So because sun is variable in any areas in Tanzania, it's equator. So that's good environment for solar power generation, but they don't have enough petroleum or this gasoline kind of fuel. So my idea is to charge the electric motorbike by the solar power plant. And then we have a 5 plant around, so they can move around the villages to village by this motorbike. That's our concept. Yeah, so we had a ceremony sometimes. This is a ceremony with regional commissioner. So the person with the yellow shirt is the regional commissioner. So he's riding the bike we made. So he said this is the first electric motorbike manufactured by Tanzanians. Okay, next. So we use different technologies. One, the motorbike on the top is use the lead acid battery. So we couldn't get the lithium polymer battery, lithium ion battery, or so we just purchased this the solar power batteries, 6 very small packs, but still runs. Right? Then we have lithium battery and this supercapacitor battery. Okay, next page. Right, and then this is Arusha Technical College in the right side. I was riding the new bike we developed, and right now we are running the road test. So in the village, the city, charging from the solar plant or charging in the regular AC outlet, And only difference is smart meter. Again, we put smart meter to the motorbike. So we could measure the power consumption and amount of the electricity remained in the battery and the location and speed of the drivers, the bike. Okay? We want to integrate those systems with the production. So this kind of data we are collecting. So we found that the cost of the electric motorbike, including the initial hardware, over time is about 1/6, 1/5 or 1/6 of the gasoline-based motorbike. Okay. Yeah, then depending on the battery, what kind of battery you use, the cost can be different. Initial cost is quite different, and overall cost can be different too. But anyway, this is cheaper than internal combustion gasoline engine. Okay. Next. Yeah, this is the same picture. So let's go next. Yeah. Right. So we have this that is 4, but because this January we had another one. So 5 solar plants in Arusha region. So I'm kind of proposing to funding agencies. Let's make like 50, 100 in this area. So making everything is electrified. Okay? Then that's kind of an empowerment of a local villager because they generated their own energy. They don't have to depending on the government. Okay? And they can use that for their lighting, right? LED light, and then for watching TV or charging cell phone. So they don't have to go for the next village or city to charge their phone anymore. Then if that is enough, right, then capacity become enough, then they can use it for charging the transportation, motorbike or even car, right? So this kind of a giving power to the local people, right? But the thing is, they don't have initiation budget. So someone should help at the beginning. But if the system runs well, then they can make this system to the next village, and then without helping of big funding from the government or other countries, they can is making the system virtuous cycle. Okay, next please. Another activity is startup incubation. And to do this, we have a program. So it's kind of a competition. We open a smart competition every year. So Korean student, Tanzanian student, maybe sometimes a US student or the French student join, and the university students mostly, and they compete each other, their ideas for the local company. And then some of funding is connected and they start a company, or even they have a company already, then we make more the progress of their company in technology or finance or funding. So this picture is this year. There's a similar idea. So those students, undergrad students, they are pretty good actually. So we teach them the designing of the bridge, and then teach them the analysis of binary element methods, kind of simulation, and competition each other, and then as teamwork. Next, please. Yeah, this is the last of technology. This is not appropriate technology anymore, but concept can be interesting because the laboratory in our lab, the lab called IDIM, we have autonomous mobile robot. So this kind of control tower of the laboratory is all connected. So 3D printer left side is connected to the robot, and right side material testing machine is connected, and then measurement machine is connected to the robot. Instead of controlling by remote control, we give a high-level command like do experiment, move to the material testing machine, and start the testing and report the experimental data. Those kind of high command language is used then by the user and remotely access the user, such as the Tanzanian student professor in the left right side computer. So we demonstrate that they can access and use our facility. Making this kind of facility requires a lot of money, but for their education and research, we can allow them to use this kind of system remotely. Then that's one of the approach, sharing the knowledge and the resources with others. So, because the Seoul National University is an education and research institute, we want to have an international collaboration, and this kind of sharing can give good leadership in our school. Next page, please. Yeah, that's it. So this is the opening ceremony of one of our sort of power plant. So far, we believe that this kind of small activity, small power plant is not that meaningful sometimes, but with some scope, right? 400, 500, or even smaller than 300 people in the village. We make them connected by the electric power and then work together and import their lives and then some of resources like water, electricity, sometimes farming and chicken farming. And then they can have a better life, and then later on, send them to the college in their local area. And then now we invite some of the Tanzanian students in our laboratory department. So all of Tanzanian professors in Seoul National University for master's and PhD degree. So once they get the degree and return, then they can empower their people with knowledge. So that's my story. Thank you very much for your attention.
교수님 혹시 질문을 한두 개 정도 받아주실 수 있으실까요?
네,
Okay, so
괜찮습니다.
if you have any questions, we can have maybe 2 questions. Yeah, please, would you come up and speak? Give a short introduction of where are you from.
Okay. Thank you indeed for your sharing. I am Tiana from Madagascar. I have just one question. Even it's not a question, but a manifestation of interest. I think that it's normal if I tell that your research and your intervention can interest different villages in Madagascar. Mainly if it taught above improve the needs of rural population and to preach the gospel. So I think that I want just to know if it is some process to manifest our interest with your institution, or how should we do to have a collaboration like Tanzania Institute, university, or inside of a community. Thank you.
Okay, thank you for your question. Yeah, I got this kind of a request sometimes from different countries. When you focus on Nepal, I got requests from Tanzania, but that time I said, yeah, no way, I cannot go to Tanzania. I need to go to Nepal. Going to Nepal is, busy enough, right? Something like that. But now I moved to Nepal. I mean, to Tanzania, and there, I think there are two ways. One is through the government, or government to government. Our project is part of a Korean government official development assistant, okay, ODA. So for that process, it takes time, but a good thing is that for some years, funding is secured. Okay? So that means your government, local government, and some of counterpart, right? In Madagascar, maybe you have a university of Madagascar or something like that. Request this kind of solar or whatever. It doesn't have to be energy, right? Any education related issue is needed in Madagascar, then you send that to Korean government, Ministry of Foreign Affairs, right? So through the embassy first. Then, if Korean government discuss and decide, yeah, let's have the project with Madagascar, then they have the joint process. Maybe it takes about a year or two. Then the government funding is given to the activity. So if you become the principal investigator or principal manager of this project, then you can do very similar way. Right? So that's one way. Similarly, you may get the request to the World Bank or African Development Bank, kind of international organization. Right? Then they like your proposal, then you can get funding. Another way is not government, but maybe NGO or church, right? Or some churches do this. Big churches, they have the missionaries, right? So missionary is usually having the preaching and then meeting people and giving the Bible and then spreading the gospel. But nowadays, the business admission, right, BAM, is popular. Our activity kind of a BAM, right? Because we are not just teaching them, right? We try to do some more like economic system, right? So empowering the local people with energy, and the local people get resources and the income. And the best example in our church missionary at KOICA. KOICA is the Korea funding agency of this kind of work, the largest funding agency in Korea for this ODA. Got this, I think, 300,000 US dollars, something like that, for the of a factory, right? Factory in Cambodia. Then through this factory, he employ people, local people, but his company pay enough, well enough. So local people like the company, and they got influenced by the missionary. Then they built a church inside of the factory. Right? So the factory worker come to the church, automatically, because they like it, and then it's kind of missionary, right? But the funding was KOICA. It's not from the church. Some big churches in Korea or other US or other countries, maybe in Malaysia, if you have those kind of large churches, then they have enough money to do this. Right? So that's another way I can think of.
Thank you.
Okay.
We may have one more question. We may have one more question, or we may just move on. So if you have any question, 네. 리소스 물이? 수력 지금 한국 분이 질문하시는데요. 수력 발전 세우셨을 때 물이 떨어지지 않는지를 미리 조사하고 하셨는지를 물어봅니다. 영어로 하면 his question is whether Professor Ahn did research to make sure that the water will not stop if there's enough water for the water power generation. 네.
Yeah, from the video of the small fall, that's the picture to measure the water amount, but the water level change over seasons, right? So Nepal and probably Malaysia is the same. Very good reason because that's a tropical or subtropical, semi-tropical. So you don't have dry up of water like Korea. Korea in the winter now it is -7 degrees, so it's freezing. No water in the winter, so we cannot run. But in altitude of the 20, right? Nepal, that village was 27. So Malaysia even lower. So you have a water source entire month, right? So the worst case in the winter maybe December, January, February. If you see water flowing in the stream, then that's enough. Okay? The thing is, you need to have a valley, some steep valley to get the water ahead about 100 meters. So that's one of geographical condition you need to think of.
Thank you very much, Professor Ahn. So we can move on to the next program. So let's give a big hand.
Yeah, thank you very much. Enjoy your conference.
네, 감사합니다. 네.
네, 안녕하세요.